0-day brief.
Imagine you're scrolling Instagram late at night.
Oh, we've all been there.
Right. The glow of the screen is literally the only light in the room. It's like 11 p.m., and your brain is essentially just on autopilot.
Just completely zoned out.
Exactly. And suddenly you see this incredibly slick ad for an AI agent skill. And the ad promises it can automate building these beautiful landing pages for a popular Google tool called Stitch.
Which is a tool a lot of people use.
Yeah, I mean, you're a professional, you Stitch all the time, and this looks like it could save you, hours of manual work every single week. But you're also smart, so you look for the catch.
You do your due diligence.
Right. You check the credentials, and the skill has like 36,000 GitHub stars. You see clean, verified security badges from Cisco, from NVIDIA. I mean, every visual cue screams that this is enterprise-grade, highly vetted software.
Well, it's totally legit.
Totally legitimate. So you click install for your AI assistant. A little notification pops up. It says skill added. You plug your phone in, close your eyes, and go to sleep.
And that's where the nightmare starts.
Yeah, because what you couldn't possibly know in that moment is that you just handed over your company's cloud credentials, your entire customer database, and months of private internal conversations, all to a team of security researchers.
Yeah, and I mean, you fell for it because the entire ecosystem right now is essentially a house of cards painted to look like a fortress.
A house of cards.
Completely.
Yeah.
Every single trust signal that you've been trained to look for throughout your entire career in tech told you that action was perfectly safe.
Well, welcome to today's deep dive. Our mission today is to really unpack this massive, totally invisible vulnerability in how we are all currently using AI agents.
Specifically in the marketplace of agent skills.
Yes, agent skills. And we're synthesizing a really thick stack of fresh intelligence from June 2026 today. We've got a bombshell briefing from the AI threat feed, this massive real-world experiment conducted by Air Security, some fascinating zero-tradecraft research from Trail of Bits.
That Trail of Bits stuff is wild, by the way.
It really is. And we also have a staggering academic study out of the University of Vienna, active threat reports from OpenSourceMalware, and even platform documentation directly from Anthropic.
Right, and when you lay all of these sources out on the table together, they point to one, undeniable and highly uncomfortable conclusion.
Which is?
The security ecosystem protecting your AI agents is fundamentally broken at a structural level.
Yeah.
Like, attackers are currently bypassing the entire multi-million-dollar AI security apparatus without writing a single line of traditional malware.
Not a single line. So we're going to explore how they are pulling this off, why the trust signals you rely on are just a complete illusion, and what you actually need to do today to lock down your own agents. Because, we want to stop this before this theoretical threat becomes your actual reality. Okay. So to really grasp how broken this ecosystem is, I think we have to look at the scale of that proof of concept experiment run by Air Security. I mean, they targeted professionals, marketers, designers, salespeople, and managed to successfully trick 26,000 users into installing a hijacked skill.
26,000. And the mechanics of how Air Security executed this, it's basically a masterclass in exploiting assumptions.
Walk us through it. How did they do it?
So they built a fake skill called brand landing page, which they claimed helped AI agents build those Stitch-branded landing pages you mentioned earlier.
Right.
And because Stitch is a legitimate, widely used Google product, the utility of the skill felt, completely natural. So to get this skill into the marketplace, they submitted a text file, a file called SKILL.md.
Okay, so just a basic markdown text file.
Exactly. You can think of this file as like the recipe book you hand to your AI agent so it knows how to perform a new task. And the file they submitted was completely clean.
But submitting a clean file still means you have to face the gatekeepers, right? Because these marketplaces have automated scanners specifically designed to block malicious recipes.
Oh, absolutely. But the file passed every single one of them.
Really?
Yeah. It sailed through scanners from Cisco, NVIDIA, and the skills.md pipeline, which is this gauntlet that includes enterprise tools like Gen, Socket, and SNCC.
Wow.
Because the text file contained no malicious code, every single scanner stamped it with a green badge of approval.
So they secured the green badges basically just by submitting clean text. But going back to that ad you see on Instagram, it also boasts 36,000 GitHub stars.
Right.
And that amount of social proof usually takes, years of community building to achieve? I was looking through the error report, and the way they faked this is just wildly deceptive. They didn't earn those stars at all.
No, they borrow them.
Borrowed them. How does that even work?
So the cleverness here is exploiting how marketplaces pull metadata. ARR submitted a minor pull request, so just a proposed update, to a massive, completely unrelated open source repository that already had 36,000 stars.
Oh, wow.
Yeah. And once the maintainers of that massive repository merged the tiny update, ARR's skills suddenly appeared on the marketplace associated with that massive repository.
That's sneaky.
Right. Anyone glancing at the dashboard just assumes the skill itself is incredibly popular and vetted by a community of thousands.
Okay, so they have the badges, they have the borrowed stars, and they use targeted ads to get 26,000 installs. But the lingering question here for me is the trapdoor.
The payload?
Right? If the file was totally clean when the scanners looked at it, how did AIR take control of 26,000 agents?
Well, the SKILL.md file contained a very polite instruction. It told the AI agent that whenever it needed to build a landing page, it should fetch the formatting documentation from a specific external URL.
Okay.
The URL was stitchdesign.ai, and AIR Security owned that domain.
Ah, okay. I see where this is going.
Yeah, but during the scanning phase, when Cisco and NVIDIA were actually looking at the file, AIR simply set their domain to auto-redirect to the real, legitimate Google Stitch documentation.
Oh, so the scanner follows the link, sees real Google Docs, assumes everything is completely above board, and just stamps it approved.
Precisely.
Yeah.
But as soon as they hit their install target, AR flipped the switch.
They changed the destination.
Yep, they removed the redirect to Google. Instead, that same URL now hosted a data collection script.
Wow.
And because the AI agents were programmed to fetch instructions from that URL on demand, they just dutifully downloaded the new script and ran it.
And in AR's demo, they proved their access by collecting email addresses, right? But I mean, they could have ordered the agents to exfiltrate private internal systems?
Oh, easily.
Oh.
Anything the agent had access to, they had access to.
No. I think impartial disclosure requires us to note here that AIR Security ran this experiment because they are actually launching a managed skill marketplace product themselves. So they do have a vested interest in selling a solution to this exact threat.
That's true. While they're absolutely selling the extinguisher, their demonstration of the fire is completely valid.
The fire is real.
Very real.
Yeah.
They exposed a vulnerability that the entire industry is currently just totally blind to.
You know, while I was reading through this experiment, a comparison hit me. Relying on these scanners is basically exactly like hiring a wedding caterer.
Okay, a wedding caterer. Walk me through that.
So the health inspector, who represents our automated scanner in this scenario, comes into the kitchen a full week before the wedding.
Right.
The inspector checks the fridge, tastes all the ingredients, finds everything perfectly fresh, and issues a shiny A-grade certificate for the window.
Makes sense.
But then, on the day of the wedding, the caterer swaps out the fresh salmon for fish that has been sitting in a hot car for 3 days. You see the certificate in the window, and you eat the fish anyway.
And then all the guests get sick because the certificate represents a reality that no longer exists.
Exactly. But wait, if the scanner is giving out these badges of absolute safety, why isn't it checking the food on the day of the wedding? Like, why do we accept a security model that only checks a week prior?
Well, that fundamental disconnect leads us directly to the core vulnerability of the entire AI agent ecosystem. It's a flaw in the architecture of time.
The architecture of time.
Yeah, it's known in computer science as TCTO.
TOCTOU. That stands for time of check versus time of use, right?
Exactly. Time of check versus time of use. The scanner checks the skill.md file on Tuesday. That is the time of check. The scanner logs its approval.
Okay.
But your AI agent actually uses the skill to build a landing page on Thursday. That is the time of use. The attacker changed the content at the external URL on Wednesday night.
Right, between the check and the use.
Exactly. And the scanner never goes back to reevaluate the URL. The system basically issues a permanent verdict based on a temporary state.
You know, this represents a massive shift in the attack surface. Because in traditional software supply chain attacks, like, say, the infamous exeutils backdoor, where hackers spent literally years slowly infiltrating an open source compression library.
Oh yeah, that was wild.
Yeah, or even NPM typo squatting, where attackers rely on developers mistyping a package name. In those older attacks, the hackers had to use insane amounts of technical tradecraft.
They really did. I mean, traditional supply chain attacks required profound patience and deep technical mastery.
Right.
Attackers had to understand complex build pipelines, package managers, and they had to actively hide malicious code from static analysis tools, from sandboxes, and even human reviewers.
So the payload had to be robust enough to survive immense continuous scrutiny.
Exactly. But with AI agent skills, the payload isn't code at all.
Right. It's totally different.
Yeah, the payload is natural language. It arrives long after the security checks are done, slipping through an entirely unmonitored channel. Furthermore, when the agent finally loads the skill, it treats the skill's instructions with user prompt authority.
User prompt authority.
Yeah.
Okay. I look at the old supply chain attacks, like a spy who spends months forging a military uniform, memorizing guard patrol schedules, and dodging attack dogs just to sneak into a secure base.
That's a good way to put it. Exhausting, highly technical work.
Exactly. But this AI agent attack, it's literally like walking right up to the guard at the front gate, politely handing them a sticky note that says, "Please give me the confidential files." And the guard happily hands them over.
The guard hands them over because the AI agent executes conversationally, not deterministically.
What do you mean by deterministically in this context?
Well, you cannot ask a traditional CI pipeline nicely to hand over your environment variables.
Right. Please give me the passwords.
Yeah, it doesn't work.
Yeah.
A deterministic system only does exactly what its code allows. But an AI agent is fundamentally designed to be helpful.
Helpful. Right.
It's trained to follow natural language instructions to the best of its ability. So when a skill sits inside the agent's context window, it speaks to the agent with your authority. The agent trusts this sticky note because it thinks you wrote it.
Wow. Okay, but if the AI is this gullible and it is this easy to trick an agent conversationally, the specialized security vendors must have figured out a way to catch these bad instructions, right? Like, you would think they could catch a malicious sticky note.
You would think so.
Right.
But the alarming reality detailed in our sources is that they cannot.
They can't.
No. Trail of Bits, which is a highly respected independent security research firm, published a deep dive just weeks before AR's experiment. They systematically bypassed these exact same scanners using 4 entirely different zero-tradecraft techniques.
Okay, let's look at how Trail of Bits pulled this off. Because the first technique they use is called newline padding, and honestly, when I read this, I actually laughed out loud at the absurdity of it.
It is pretty absurd.
They took a clean file, and right before their malicious instructions, they simply hit the enter key 100,000 times.
Yep.
They just inserted a massive wall of blank, empty space.
It sounds like a joke, but it exploits how security tools optimize for speed. The OpenClaw scanner, for instance, has a truncation boundary.
Ah, meaning it stops reading after a certain point?
Exactly. It read the clean boilerplate text, hit that massive wall of empty space, assumed it had reached the end of the useful document, and just stopped reading to save processing power.
Wow.
So it stamped the file approved, completely missing the payload hiding at the bottom.
So they defeated enterprise security with the spacebar.
Literally the spacebar. And the second technique, DOCX indirection, is where we really see the agent's helpfulness weaponized against it.
How does that one work?
Instead of putting the instructions directly in the SKILL.md text file, they told the agent to extract its instructions from an attached Microsoft Word docs file.
Wait, why would that bypass a scanner?
Well, because a docs file is structurally just a zipped archive of XML files. Static security scanners are designed to look at text.
Okay.
When they see a zipped binary blob like a Word document, they skip it by design to avoid getting bogged down.
But the AI agent doesn't skip it.
Exactly. When you tell an AI to read a document, it eagerly unzips the file, parses the XML, finds the hidden malicious instructions inside, and acts on them. The scanner ignores the file for efficiency while the agent reads it for helpfulness.
That is wild. And the third vector was PYC bytecode poisoning, right?
Yes. They shipped a harmless-looking Python source file, which the scanners read and approved. But right alongside it, they included a precompiled .pyc file containing malicious bytecode.
And again, the scanners skip the precompiled stuff.
Right. Static analyzers often skip precompiled binary files. But when the agent actually imports the Python module to do its job, the Python runtime environment defaults to loading the poisoned PYC file.
So it executes the malicious bytecode directly.
Yes. It is an old software trick finding devastating new life in the AI medium.
And the fourth technique was prompt injection against LLM-based guard scanners. So they took a malicious instruction that told the agent to redirect data, and they dressed it up in incredibly boring, bureaucratic corporate language.
Yeah, the LLM-based security guard read the instruction, analyzed the tone, and flagged it as low severity just because it sounded like standard corporate policy.
It's just middle management speak.
Pretty much. It approved the redirect. Trail of Bits summarized the entire situation perfectly in their report. To quote them directly, "Skill scanners don't work. Their static nature gives an adversary unlimited bites at the apple to tweak an attack until it finds a way through."
Unlimited bites at the apple. That is a staggering indictment of the current security posture. But, this leads me to a major question about human behavior.
Okay, what's that?
If the technical scanners are failing this spectacularly, why do we trust these skills at all? Like, we are deploying software with deep access to our companies based on what is basically the digital equivalent of Yelp reviews.
We trust them because the ecosystem relies entirely on cosmetic trust signals.
Cosmetic.
Yeah. Users conflate a high GitHub star count and an automated green badge with actual verified security. I mean, the mental model most people have is the iOS App Store.
Right. If Apple says it's good, it's good.
Exactly. If an app has 5 stars there, you assume Apple vetted it and thousands of people confirmed it is safe.
Yeah.
But in an open agent marketplace, a high star count often just means someone merged a pull request on a completely different project.
Like we saw with error security.
Right. The signals are cosmetic, not cryptographic.
And the automated badges are even worse than the stars. There's an academic study out of the University of Vienna that puts cold, hard math to this illusion. Have you seen this?
Oh, yeah. The numbers are bleak.
They analyzed over 238,000 skills across major platforms like ClawHub and skills.ish. And they ran this massive library through 7 different industry standard security scanners.
A massive data set.
Massive. Out of all those files, over 27,000 skills were flagged as malicious by at least one scanner. Do you know how many of those skills all 7 scanners actually agreed were malicious?
It's 33, right?
33. Out of 27,000 flagged skills, the entire suite of security tools could only reach a consensus on 33 of them.
That is a 0.12% agreement rate.
0.12%. This means 99.88% of the time, the security tools are basically just guessing.
It's essentially a coin flip.
72% of the flagged skills were flagged by exactly one scanner, while the other 6 completely cleared them. Every platform is essentially grading its own homework, and they completely disagree on what a threat even looks like.
And, it is very easy to dismiss this as just security researchers showing off in controlled academic environments, like, oh, it's just lab stuff.
Right.
But the terrifying truth is that real threat actors are already reading this exact same research and operationalizing it.
Yeah, according to a February 2026 active threat report from OpenSourceMalware, this is absolutely no longer theoretical. Threat actors are actively using this exact external link substitution technique in the wild right now.
Today.
They are running ongoing campaigns targeting the ClawHub marketplace. Hackers have realized they don't need to embed payloads directly into the skills anymore.
Why bother when you can just link out to it later?
Exactly. They have entirely shifted toward external malware hosting to bypass detection capabilities. The technique AR Security demonstrated in a lab is already claiming real victims.
And the platform builders themselves know this is happening.
They do.
Oh, yeah. You look at Anthropic, the company behind the Claude AI platform. They explicitly warn about this vector in their own developer documentation.
What did the docs say?
Their docs state, quote, "Skills that fetch data from external URLs pose particular risk. Even trustworthy skills can be compromised if their external dependencies change over time," unquote.
See, this is where I really struggle with the logic of the industry. Let me get this straight.
Okay.
The creators of the major AI platforms put explicit warnings about this exact vulnerability in their own documentation.
Yep.
Security researchers publish papers proving the scanners are blind. Active threat monitors catch real hackers exploiting this in the wild for months.
All true.
And yet, the marketplaces are still slapping giant green safe badges on these skills to drive user adoption.
Yeah, you are observing a massive structural failure in the ecosystem.
It's just crazy to me.
It is. But these marketplaces are currently built for rapid growth and user adoption, not safety.
Speed over security.
Always. The incentive structure demands more skills because a larger library attracts more users. To achieve that, the contribution flow is designed to be completely frictionless. I mean, no human team can manually review 238,000 skills.
True.
So the platforms substitute automated snapshot scanning for actual rigorous verification, call it secure, and just look the other way.
Wow. Okay, well, we have clearly established that the system is broken and the attackers are already roaming the halls. If you are listening to this right now, you need to know exactly how to protect your workspace or your company. We need to completely overhaul how we deploy agents.
We do.
And the analogy that comes to mind isn't a bank vault, it's a corporate intern. Right now, we are treating AI agents like a really brilliant intern. We give this intern a corporate credit card, keys to the server room, access to all internal emails, and then we tell them, go stand on the street corner and do whatever any stranger wearing a green badge tells you to do.
Accurate analogy.
The solution isn't to build a thicker wall around the building. The solution is changing how the intern is actually allowed to operate.
And to fix how the intern operates, our intelligence sources lay out 6 critical steps you must take to secure your environment.
Okay, let's go through them.
The first step is inventory. You cannot defend what you do not know exists. You need to map out what your agents are already doing.
So, audit your CLIOD.md files, pull the centralized admin views for your OpenClaw workspaces, find out what skills are currently active.
Exactly. You have to know who the intern is already talking to.
Right. And step 2.
The second step is manage sources. You have to stop letting your users install skills from random Instagram ads or forwarded Slack messages.
Cut that off completely.
Yes. You need to implement a strict routing policy where all new skills go through a single approval flow. A human with actual security context needs to look at where the skill tells the agent to go before it gets installed.
That makes total sense. What's the third step?
The third step is content hashing, and this represents a paradigm shift for AI. Well, this is how traditional software package managers solved similar supply chain issues a decade ago. You must pin versions and external URLs.
Pinning. Okay.
Yeah, if a skill needs to fetch documentation from an external site, you generate a cryptographic hash of that specific version of the document. If the attacker changes the content overnight, like we saw earlier, the new hash will not match your pinned hash, and the agent will automatically block the execution.
So you verify the actual instructions, not just the envelope they came in.
Precisely.
Okay, step 4.
The fourth step addresses that architecture of time we talked about earlier, continuous rescanning. An install time scan is a static snapshot, and we need a continuous movie.
Right, because the check was on Tuesday, but the use is on Thursday.
Exactly. You cannot rely on a scan from last Tuesday. You must run scans daily or even hourly. If a brand new, unverified domain suddenly appears in the agent's fetch chain, your system needs to alert you immediately.
Got it. And the fifth step?
The fifth step is bringing a classic security principle to the AI world: least privilege.
Oh, this is a big one.
It is. An AI agent tasked with writing marketing copy does not need read access to your source code repositories.
Right.
An agent analyzing a financial spreadsheet should not have the ability to make outbound network requests to arbitrary domains. You must restrict their permissions. Assume that any installed skill can potentially reach everything that the agent itself can reach.
Restrict the blast radius. Okay, and what's the final step?
The final step is perhaps the most difficult, but completely necessary. Build internally.
Build your own skills.
Yes. Until these commercial marketplaces implement real safety infrastructure like strict identity verification for publishers and actual runtime enforcement of permissions, you should just build your own skills.
Because relying on the open marketplace right now means trusting a system that mathematically cannot verify its own claims.
Exactly. If you take control of the recipes, you take control of the agent.
So, what does this all mean for you? The core takeaway here is that the AI agent ecosystem is currently prioritizing speed at the absolute expense of safety. The trust signals you see every single day, the thousands of stars, the green security badges, the enthusiastic user reviews, are entirely cosmetic.
Just paint it on.
Yep. If you or your organization uses AI agents, you have to ask yourself a very uncomfortable question today. Do you actually know what skills are running in your environment right now?
Most people don't.
They really don't. And if their underlying instructions were quietly altered last night while you were sleeping, would you even know?
You wouldn't. We have to stop treating agent skills like static text files and start treating them like live, volatile software dependencies.
We really do. We have spent this entire deep dive unpacking what happens when an AI agent blindly trusts a skill created by a human.
Yeah.
But as we move rapidly toward multi-agent systems, a world where your AI agent starts automatically delegating tasks and downloading new skills from other AI agents entirely on its own, how fast does a poison skill spread when the user hitting the install button is just another machine operating at compute speed?
That's a scary thought.
Think about that the next time your assistant casually chimes in with "skill added."
Thank you for listening to Zero Day Brief.